which dries clothes faster, a cold dry day or a warm humid day? And how does evaporation actually cause cooling? Let us go deep into the invisible world to understand this.
Hi, I'm Sohail, a passionate STEM based chemistry educator. I love visual storytelling and I am constantly growing in this. Before we start, let us quickly recall something important.
In solids, particles vibrate at fixed positions. Now the question is, why cannot we perceive such motions? Because we observe matter at a macroscopic level, not microscopic. Therefore, these molecular vibrations cannot be perceived. In liquids, particles can slide past each other and also vibrate. That is why they are called fluids and have more kinetic energy than solids. And in gases, particles move randomly with maximum kinetic energy and almost no forces of attraction. For now, let us focus on liquids. Here is a surprising fact. The white fog or cloud you see is actually made of tiny liquid droplets. When we zoom in, we see countless water molecules, and these molecules are in continuous random motion. Molecules are constantly colliding with each other. So, some molecules have low energy, most have average energy, and a few have very high energy. So, at any moment, some molecules gain kinetic energy, and these become fast high energy molecules. But even these fast molecules may not escape because they can collide again and lose energy. Now, here is where things get interesting. Surface molecules are different because they have fewer neighboring molecules, only sideways and downward. So, the intermolecular forces are unbalanced. That means it is easier, not easy, but easier for them to escape, while bulk molecules are surrounded on all sides. So the intermolecular forces are strong here. To escape, a molecule must overcome the attractive forces holding it in the liquid. A high energy molecule at the surface tries to move away, but it still feels a pull backwards. And here is a key idea. Kinetic energy alone is not enough. If all its energy is used just to fight attraction, it may lose energy and fall back into the liquid. So, what is the missing piece? The molecule can absorb extra energy from the surroundings or nearby molecules. This energy is called latent heat of vaporization. This energy does not increase speed. It is used to increase potential energy. Now let us understand potential energy. In simple words, it means energy stored in a system or object due to its position. Imagine a ball rolling up a hill. Its kinetic energy helps it climb. As it climbs, speed decreases, height increases. So, at this point, kinetic energy is converted into potential energy, which increases separation between molecules. Since intermolecular forces act only at very short range, once the molecule is far enough, there is no pullback. Now the question is, when does it come back? A molecule will return or condense if it loses energy in collisions, comes near the surface again, and gets pulled back. Now let us understand cooling due to evaporation. Imagine a system with 5 molecules having energies 10, 5, 4, 3, 3 quanta. Average of these molecules comes out to be equal to 5. Now the highest energy molecule with 10 quanta energy escapes. The remaining molecules are 5, 4, 3, 3. The new average drops and comes out nearly equal to 4 quanta. Since we know temperature depends on average kinetic energy, as new average drops, which means the temperature decreases. This is how evaporation actually causes cooling. Now the final question. Which dries clothes faster? Clothes on a line on a cold dry day or on a hot humid day? On a cold dry day, the water in the clothes does not get as much energy for evaporation, so evaporation is slower compared to a hot day. On a hot day at around 35 degrees Celsius, evaporation is generally faster because molecules have more energy. But here is the twist. If the atmosphere is very humid at 35 degrees Celsius, even though water evaporates quickly, it also condenses back onto the clothes more easily. So, evaporation and condensation are happening at the same time. Another crucial factor is wind. Wind removes the water vapor around the clothes, allowing more evaporation. On a cold, dry day, the vapor is easily carried away, but on a hot, humid day, the air is already full of water vapor, so drying becomes slower. So, which dries clothes faster? It actually depends on how dry the cold day is and how humid the hot day is.